Unit 5 is about introductions to exponential functions. Has anyone ever heard of exponential functions before? Yeah. You ever heard of exponential before?
I've heard of it, I just don't know it.
You don't know too much? What about you? You ever heard the word exponent?
Yes.
So it's like exponents. Like if I say 2 to the first power, what's 2 to the first power?
2.
2. If I say 3 to the second power, yeah, better not say 6. 9. 9. Good. Shut up. Learning target. Zeta, read our learning target, nice and loud.
I can compare growth patterns using calculations and graphs.
Good. I can compare growth patterns using calculations and graphs. These are some bacteria in a dish. Every hour, each bacterium splits into 3. So the diagram shows the bacterium in hour 0 and then hour 1. So draw what happens in hour 2 and 3. So we just talked about exponents, right? So I want you guys to keep that in mind when you're thinking about how the bacteria splits. Alright? The bacteria is going to split into what? What does it say?
3.
It splits into 3. So we're not doubling, we're what? We're tripling, okay? So whenever we're tripling, that number that we're like splitting it by is going to be the base of our exponent. Alright, so 3 to the 0 power. Anything to the 0 power is what? 1. Okay, good. So now this is 3 to the first power, which is why, how many bacteria do we see? 3, okay? So now they're asking for hour 2, and they're asking for hour 3, alright? I want everybody to take 2 minutes, and not only are we gonna write the number of the bacteria, but we're gonna draw the bacteria out. So I'm gonna give you guys an idea of what I'm talking about. You don't need to make a perfect image, Aiden. You don't need to make a perfect image, okay? You can draw a circle with a dot inside just to show that it's a bacteria, okay? So the main point of this is not so that we're working on our class and we're not working on science. I just need you guys to understand that when you're tripling is a lot different than when you're multiplying, right? So here's what I mean. 3 to the first is not the same thing as 3 times 1. Yes, I know you get the same number, but eventually over time you're not going to do that. 3 to the second is not the same as 3 times 2, right? What do you do when you get 3 times 2?
6.
You get 6. But when you get 3 to the second, what do you get?
3 times 3.
Which is?
9.
9, exactly, right? So they're different things. Exponential and this would be like linear are different things. Because this is going up by a constant, right? Because like if I do 3 times 3, what am I going to get? 9. I'm going to get 9, right? And if I did 3 to the third, what am I going to get? 27, right? So over here, these numbers go up by the same amount. They go up plus 3, plus 3. While over here, they don't go up by the same amount, all right? They get multiplied by 3. 3 times 3 is 9, 9 times 3 is 27. So this is a constant change, and this is not a constant change. That's how exponential functions grow. And they can decay like that too. So I want everyone to move on to the next page.